first value of that coordinate always gonna be 0, very good. Alright, so again, that basically is just the process we worked on yesterday. We're gonna do an example on the inside, but y'all pretty much know how to do that anyways. Alright, method 2, and this is my favorite because it's the lazy way.
Oh, yeah.
Yay.
I love the weekend.
I know, I figured. Method 2, find and graph x and y intercepts. Find and graph x and y intercepts. Alright, so we sort of alluded to this yesterday. If the y-intercept is where the line crosses the y-axis, what would you assume the x-intercept is?
Where the line crosses the x-intercept.
Where the y crosses the x-intercept, can you think of a situation where a line would not have both? Discrete graph?
When the line crosses 0, the line
That's possible if it's nonlinear. Can you think of a situation where a linear would not have both?
When it crosses 0,
If it was undefined.
If it's undefined.
If it's undefined, which looks like what? What kind of line is that?
A vertical line.
Vertical, very good, and, or if it were what?
Zero.
Meaning, what kind of line is it? Horizontal, very good. So if you've got a vertical or horizontal line, it's not necessarily gonna have both. If you have a horizontal line, it's only gonna have what, intercept? Horizontal? What's that look like?
Y.
So it'll have a y-intercept, and if it's vertical, it's gonna have which one? X, very good. Alright, so to find the x-intercept, that goes on this little part right here. I'm gonna tell you what's right there. Plug in 0 for y, and solve for x. To find the y-intercept, plug in 0 for x, and solve for y. Again, for the x-intercept, plug in 0 for y and solve for x. To find the y-intercept, plug in 0 for x and solve for y. Why do those directions make sense? Okay, you said they're opposites? So she's saying for the y-coordinate, or not for the y-coordinate, but for the y-intercept, think about it, it's going to be a coordinate, correct? And where's that coordinate going to be? On the y-axis. Everywhere on that y-axis, what's the x value?
0.
0. So what they're saying basically is assume x is 0. What does y have to be in that situation? Same thing for the x-intercept. Where is that going to be at? Where's that going to be at, x-intercept? On the x-axis. What do we assume everywhere on the x-axis? Y is what? 0, which is why we have these rules that we can plug in the number and solve for x or y. Alright, so let's make that happen.
Graph your intercepts and connect.
Yes. Let's do an example. Alright, on the inside, I want you to write on both sides the same equation. We're just going to do it both methods. Method 1, method 2, and then we're also going to go back and do method 3. And let's use the equation. 3x plus 5y equals 15. 3x plus 5y equals 15. equals 15. We're gonna use that same equation for both methods. I'm gonna give you two little sticky notes of graph paper and you'll put one on each side. Alright, let's go ahead and do method one, which was what? Turn it into slope-intercept form, that's basically what we did yesterday. Please take that equation and put it in slope-intercept form for me. Take that equation for method one, put it in slope-intercept form. What did I give you there? Huh? Just put it in slope-intercept form. Anybody feeling really smart? You've already got it in slope-intercept form, and you'd like to share. Abby, go right on the board what you got. Davis, have you done this problem?
I was just writing it down.
Go ahead and finish the slope-intercept form.
I write up here which.
You'll have to write it on the whiteboard.
Okay.
We had that conversation. Yes, ma'am. Everybody got two graphs?
Are we still starting this year?
No, not yet. Alright, what do you think about that?
I like it.
She put y equals negative 3 over 5x plus 3x.
No, it's on the three.
No X.
It shouldn't be. Yeah.
It should be an X on there.
No x on the 3?
That was on your graph.
Oh, okay. Everybody good with that?
Yes.
Yes?
Bravo.
Wonderful. Go to the bathroom for bathroom.